Okay, let's get started with 0.7 complex numbers. So what are we up to with complex numbers? We are going to write radicals. Remember, a radical is the square root or cube root, cube root symbol, fourth root, fifth root, whatever, with negative radicands. So the number underneath is going to be a negative. We're going to write those as imaginary numbers. So we'll get into what that means throughout this unit. Okay, and then we'll do all of the mathematical operations with them. We'll add, subtract, multiply, divide, and we'll raise two powers. Two big takeaways: we will understand that real numbers and imaginary numbers make up the complex number system, and we'll understand how to eliminate imaginary numbers in the denominators. So if it helps you to get all of the formulas down, first pause the video and copy this down. Otherwise, we're going to keep rocking and rolling, and we'll cover all of this in the next few minutes. So what happens when you square root a negative? Well, so far we've said it cannot work, because if we said square root of negative 16, what number times itself gets us to negative 16? It's not going to work, right? Either negative 4 times negative 4 or 4 times 4. So we're going to, and so there are no real numbers that work. But we can introduce imaginary numbers, and we're going to do this with the base imaginary number I. I is defined as the square root of negative 1. All right, and then if we squared that, square root of negative 1 times the square root of negative 1 would just be negative 1. So I squared is negative 1. I is the square root of negative 1. How does that help us? So if we are square rooting something with a negative in the radicand, we can pull the I out front. So something like the square root of negative 16, we could rewrite as I times the square root of 16. And the square root of 16 is 4, so we would write 4I. All right? So, and we always write the I out front. That's what this is saying here, instead of something like square root of 16I, because we want to make sure that it's really clear that the I is outside of the radical and not underneath it. It's making sure, is the I underneath, not underneath? We're not sure. Just write it out front. Makes it much more clear. All right, so let's give this a shot. Square root of negative 9. We're just going to write the square root of negative 1 times the square root of 9. And we can shortcut that going straight to I times the square root of 9. What's the square root of 9? Say 3. So we'll say 3I. All right, next one, we'll jump straight to pulling the I out front. Square root of 8. And the square root of 8 can be broken up into the square root of 4 times the square root of 2. The square root of 4 turns into 2I square root of 2. All right. Your turn. All right, so hopefully you paused that and tried it. You should have an I out front of 144, and so we'll get 12I. Okay, a complex number in standard form is defined as A plus BI, where A is the real part and B is the imaginary part. So we're going to say real plus imaginary. That's how you make up a complex number. Now, if you only have the imaginary part, it's still a complex number. If you only have the real part, it's still a complex number. So the complex number system has all the reals and all the imaginaries and all the mixes of the two. All right, so we're going to add and subtract these just like we would with normal variables. So I is representing the square root of negative 1, but it works just like if we were adding x's or y's, right? So x plus 2x is 3x, I plus 2i will be 3i. So we'll do the same thing here. We could go vertical with this if it helps. Put them on top of each other. 3 plus negative 1 is 2, and negative 2 plus I is negative 1i. Same thing here, 2 minus I minus 3 minus 4i, and we'll end up with negative 1. Negative 1 plus 4 would be plus 3i. 2 minus I and negative 1 plus 3i. All right, quick tech tip. So your calculator, just like it can add 3s and 4s, can also add imaginary numbers. We need to put our graphing calculator in A plus BI mode. So I'm going to pause the video here shortly, open up my calculator on the screen, and show you how to do that. Okay, so I've opened up my calculator. Here's your TI-84, and here's the screen. All right, so if you're using something other than the TI-84, it might look slightly different. But what we need to do is we can go into our mode screen here by pressing mode, and we're going to go down to right here where it says real versus A plus BI. Now, A plus BI, they could have just said complex, but A plus BI is a little shorter to write. We'll hit enter. To get out of the screen, here's the quit button right up here. To get the blue option, we're going to hit second quit. All right, we're back to our home screen. So let's go back to what our problem was. Let's see here. Zoom this. All right. So if we said 3 minus 2i, put it in parentheses, we're going to say 3 minus 2, and our I is right above the decimal point. You see it in blue, so we had to hit the second button, the blue button, 3 minus 2i, and plus, in parentheses, negative 1 plus I. Now, negative, right here, not minus, okay? The calculator will differentiate between the negative and the minus piece. So negative 1, what was it? Plus I. Plus second period. To get the I, we'll close our parentheses, see what we get. And there you go, 2 minus I, which is what we're shooting for. All right, so if you have your TI-84, you can try that, and we'll simplify things for you, adding and subtracting and multiplying and dividing when we get there, your complex numbers. So give that a shot with 4 plus I minus 3 minus 5i. And since that's just a punching it into our calculator, we can just put the answer up here, and it's 1 plus 6i. Okay, multiplying works just the same way as multiplying x's as well. So 3 minus I and 2 plus I, we can FOIL this. So first, outside plus 3i, inside minus 2i, and then last would be negative I squared. We'll collect this. 6 plus 3 minus 2 is just 1i minus I squared. Now remember that I squared equals negative 1 because I, the square root of negative 1, if we squared them, we would just get negative 1. So we can change I squared into negative 1. What happens if you minus a negative? You add. So we get 7 plus I. Same thing happens here if we distribute. If we distribute this in, we get negative 3i plus I squared, negative 3i plus negative 1. So negative 3i minus 1, we'll put this in standard form of negative 1 minus 3i. Okay, and there you go. So yours to try. Just a quick tip here. Of course, you can use your calculator for this as well, as long as you're in the A plus BI complex mode. All right, give it a shot. And there's your answer, 2 plus 11i. Okay. All right, so the complex conjugate, here's a more complex, no pun intended, definition, but we've looked at this before. If A plus BI is your terms, is your complex terms, A minus BI is the conjugate. If you start with A minus BI, A plus BI is the conjugate. We're just changing the sign. All right. So to write the quotient in standard form, when we divide complex numbers, we need to multiply by the conjugate. You are not allowed to have i's in the denominator because I is a radical, and you're not allowed to have radicals in the denominator. We're going to multiply top and bottom by 1 minus 3i. Minus 3i. Let's FOIL the top. We would have 2 minus 6i minus I plus 3i squared, which is, so on this one, remember that I squared is negative 1. So this is going to turn right here into minus 3. So we would have 2 minus 3, negative 1, minus 7i in the numerator. And the denominator is going to be 1 times 1. And this is the difference of perfect squares. So we can cancel out the O and the I when we're FOILing. We'll go straight to 9i squared, which is the same as saying 1 plus 9, which is 10. 10. So we'll say negative 1 minus 7i over 10. Okay. Now, the back of your textbook is going to write these as split fractions. So negative 1 over 10, negative 1 over 10, and negative 7 over 10, negative 7 over 10, I. Either way you want to write it. You can write it like this, or you can write it like this. Either way is perfectly acceptable. All right, and you can also do this in your calculator as well. Your calculator is going to spit you out a decimal, though. So how do we convert from the decimal into a fraction? You can see its answer converted into the fraction. So let's go back and do this real quick. Pause and get it set up for you. Okay, so I've entered in 2 minus 3i divided by 1 plus 3i. Notice the parentheses. It's very important to have your parentheses for order of operations to work. I hit enter, and there we go, negative 0.1 minus 0.7i. And so that doesn't help us very much. We want it in fraction form, so we're going to say convert our answer into a fraction with the math function. Math, first option right here says convert to fraction, the arrow fraction. So we hit enter, and it'll put this up, and we say, is that what we want? Yes, it is. So we'll hit enter again, and there you go, negative 1 minus 7i all over 10. All right, your turn. Multiply by the conjugate. All right, last thing we're going to do is we're going to raise complex numbers to integer powers. And so we've already seen these two, I and I squared. So let's look at the next option. I cubed can be broken up into I squared times I. Well, we already know what I squared is. I squared is negative 1. So what's negative 1 times I? Negative I. I to the fourth can be broken up into I squared times I squared. And since I squared is negative 1 and I squared is negative 1, it takes us back to just 1. From there on, it's going to repeat every fourth number, because I to the fifth can be broken down into I to the fourth, which is just 1 times I. Do we really need the 1 when we're multiplying? Not at all. So we can just write I. I to the sixth is I to the fourth, which is just going to be 1 times I squared. What is I squared? Negative 1. All right. So we see this with a couple options. I to the seventh, let's take out the biggest multiple of 4 we can, which is just 4, times I cubed. I to the fourth just turns into 1 times I cubed. I cubed is the same thing as I squared times I, and I squared is negative 1 times I, so we get negative I. So you can go through this step, or you can just have the first 3 memorized and have I cubed equals negative I for our answer. I to the 13th, what's the biggest power of 4 we can get in there? 12 times I. I to the 12th is I to the 4th times I to the 4th times I to the 4th. You don't have to write out this step here, but that is just 1 times 1 times 1, and then times the I that was by itself. So we're going to get I. And then I to the 100th is I to the 4th to the 25th power. So that's just the same as I to the 4th, which is just 1. All right, so we can also do this in our calculator. One thing that's going to come up here is this will write it in the complex form. Negative 3e to the negative 13th is how the calculator writes scientific notation. This is saying negative 3 times 10 to the negative 13th. This is 3, but 12 zeros first. Negative 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a 3. This is just a rounding error on your calculator. This is the same thing as saying 0. This is saying 0 minus I, or just negative I, all right, which is what we got before. So if you see these calculations right here, you need to get good at saying, oh, that's just 0. It's a rounding error on your calculator. Or you could do it by hand, either way. So by hand, you're going to have this one. Sorry, I almost did it for you. Pause the video, see if you can do that. And this is the last problem. And we'll see you in class tomorrow. All right, good luck. If you did this correctly, I to the 24th, which is your multiple of 4, times I cubed. So it's 1 times I cubed. And I cubed is equal to negative I. All right, see you tomorrow.